If you read carefully,
Oh, I see that.
what does it say?
Choose all that apply.
Choose all. So it doesn't look like a select all question because there's only 4 answers, but there are more than one. So if I need to use these 2 sides, what's one correct answer? Who can give me one of them? Okay, let's take a look at B. So B says the cosine of 28 degrees. Cosine, what's cosine again? Oops.
If I can remember properly, I think it's adjacent over hypotenuse.
Good, you're correct. So adjacent over hypotenuse, and now let's look at angle 28, so angle X. Which one's the adjacent side for angle X? Which one's the adjacent side? Careful, Jalen. Where is 20 located? It's located across. So 20 is not adjacent. What is it? That's opposite. Okay, so just be very careful. That's like one of the biggest, easiest mistakes to make. It's not a huge deal right now, but you want to make sure you like ingrain that into your memory, because if you make that mistake on a quiz or a test, then obviously it's going to be a bigger deal. So it's not adjacent over hypotenuse. We have opposite over hypotenuse. So what trig function is that? Good, Janelle's. It's the sine of 28, not the cosine of 28. So it's answer choice A, not B. Okay, but it's just a little mistake. That's totally okay. So opposite over adjacent would be 20 over z. And if the sine of 28 is 20 over z, then which other answer choice is also correct? Good, C. How do I know that the cosine of 62, like where did that number come from? (90 minus 28 is 62. So 62 and 90 and 28 are complementary angles. So the sine of 28 is equal to the cosine of 62. And it goes the other way around as well, right? So the cosine of 28 is equal to the sine of 62. And 62 is what belongs in here. Any questions on the bell ringer? Okay. Well, now I want to actually evaluate this. Let's solve for z. Let's figure out what is the value of z. So I can use either one of these equations, but I'll go with the first one. I'll go with sine of 28. So sine of 28 degrees equals 20 over z. In order to get z by itself, what should I do to both sides? Okay, divide by what? So z is in the denominator right now, right? We got to get him out of there, because when you're in the denominator, you need to try your best to get it out, right? So the only way to get something out of the denominator, like Perla said, is to multiply it out. So we're multiplying by z on both sides. That seems counterintuitive because usually you don't want to move the z around, but because it's in the denominator, you want to get it out of there, you got to multiply it out. So now I have z times the sine of 28 degrees equals 20. Well, what do I do now to get z by itself? Very good. We're going to divide both sides by the sine of 28. Which means you got to go to your calculator. Because remember, with these problems, you must use a calculator. There's no way around it. So in your calculator, I actually was able to download a calculator app on my iPad, so hopefully this works. But we're going to be plugging in 20 divided by the sine of 28. And you have to be very careful. You have to make sure that you're computing this correctly on your calculator. So I'm doing 20 divided by the sine of 28. So I have 20 divided by, then I'm going to use my parentheses, okay? Because the sine of 28, we need to keep that all inside of the parentheses. So what I just did is I just hit the open parentheses button. Oops, I just did it twice by accident. I think that'll be fine. Actually, let me start over. Okay, 20 divided by parentheses. Then I go and I hit 28 and the sine button. Okay, so look at what it says in the little corner right there. I did right here, 20 divided by parentheses 28 sine button. Now I have to close my parentheses and hit equals. I get 42.6. If you're getting a different number, that means you're not doing your parentheses correctly. So I'm going to do it one more time, and I want you all to follow along. No matter which calculator you're using, it's going to be the same process. Okay, so again, 20 divided by, open those parentheses, hit 28, hit sine, because we're taking the sine of 28, close your parentheses and hit equals. Is anybody still getting a different answer and would like me to try it one more time? And make sure you got the same thing. If you're getting something different, we need to figure it out now before you have to take a quiz.
That's a big calculator.
Thank you, Daniel. Okay. So no questions on how I got that number? Going once? Good. Going twice? Okay. Now, that's only if you're dividing. If you're multiplying, so let's say I had to do 5 times the sine of 28, that's a little bit easier because then all you got to do is 28, hit the sine button, multiply it times 5. A lot simpler that way. It's just harder when you have to divide. Okay. Back to it. So we got, what did we get? 42.6? 42.6. Oh, does not want to write. Hold on. I feel like my Apple Pencil is always dying during this class. I don't know what it is. There we go. Ooh. 42.6. Okay. And is that degrees or length? Is that 42.6 degrees or is that the length of 42.6? Good, length. Good. All right. So I kind of mentioned this yesterday, but we never got to it. So I want to make sure we go ahead and practice this today. One more time, with all mathematical operations, you always have an inverse. So what is the inverse of addition? What's the inverse of addition? Good, subtraction. What is the inverse of multiplication? Division. What is the inverse of the second power, going up to the second power? Good, square root. Now in this case, we have inverses for sine, cosine, and tangent. They're just called the inverse sine, the inverse cosine, and the inverse tangent. So this is how they work. Sometimes, like in this problem, we were missing the value of a side length, right? We didn't know how long that length was. Well, what are we missing in this case? The angle. Exactly. We don't know the angle measurement. We know everything else, but we don't know the angle. Well, that's where the inverse trig functions come into play. Because what we can do is we can set up an equation just like we did before, and we're going to solve that equation algebraically. But when we do so, there's going to come a moment where we have to do the inverse operations of sine, cosine, or tangent. So let's go ahead and take a look at this example. So I have this missing angle right here. I'm going to call this angle theta. And you guys are going to see theta come up, so that's why I want to bring it up. Theta is a variable that we use for angle measurements. You might have seen it on Khan Academy already. And I just want to make sure that we know what it is because it comes up a lot. It's pronounced like this, theta. And it's a letter in the Greek alphabet. So theta is just the name of that angle. And you might see a couple more, like in Khan Academy, they use a lot of different ones. I saw that they were using alpha, that's alpha. Sometimes you might see it, this letter, that's beta. And you might see other symbols, but just remember that at the end of the day, those are all just like a variable, and we usually use them as angle measurements. So if you see them come up, don't be confused by them. It's just another variable, that's all it is. But in this case, we're using theta. So if I'm looking at theta, which trigonometric ratio can I use that includes this side length and the other side length?
There. Where's Lopez?
What?
Oh, look at Mrs. St. Rose.
Oh, hi. Hi, Mr. St. Rose. I couldn't hear you because Perla's microphone is really low, so I can barely hear.
Oh, okay. Jenny said, tell Miss Lopez she did a great job today. How great a job you did, Miss Lopez.
Oh, thank you. Thank you.
Wait, what are we gonna do for your birthday?
What are you gonna do for my birthday?
Yeah.
My birthday's on Sunday this year, so there's not much we can do.
You're gonna pledge.
Yeah, we know.
That's me.
I mean, we gotta do something.
Maybe we can do something on Monday. Because Mr. St. Rose, wasn't your birthday on Monday or is it on Tuesday? Wait, I can't hear you.
Oh, I'm on the 23rd.
Okay, so you're Tuesday.
23rd.
Y'all both got the same birthday? Wait, no.
Yeah,
I'm dumb.
my birthday's on Sunday, Miss
Yeah, Miss-
Sneed's birthday is on Monday, and Mr. St. Rose's birthday is on Tuesday.
Ain't that something? My birthday's all the way in December.
This is on Tuesday.
Tuesday. Sunday, Monday, Tuesday. Great week. We have a great week, Miss Lopez.
We sure do. Alrighty.
My birthday's in 10 months.
Well, your birthday just passed. You can think about it that way.
Yeah, I know.
All right. So where was I? So which ratio should I be using if I'm talking about those two side lengths? Should I use sine of theta, cosine of theta, or tangent of theta? Okay, Emily says tangent. What do you guys think?
I agree.
You agree? Okay, good. Because the blue side, that's my opposite, and the purple side is my adjacent. So opposite over adjacent, that is definitely going to be tangent. So we're going to go ahead and we're going to look at tangent of theta is 35 over 65. Okay. So, okay, that's great. But the thing is, I want to figure out, I don't care about the tangent of theta. I want to know how much is theta. I want to know how much theta measures. So in order to do that, I basically, just like we solve for x, we're going to solve for theta. And right now, theta is kind of stuck, right? It's in that tangent function. We got to undo the tangent to kind of break theta out of there, if that makes sense. So in order to do that, we're going to go ahead and we're going to do the inverse tangent. So here's how this looks. So we're going to take the inverse tangent of both sides. In fact, let me do it this way. We're going to take the inverse tangent of both sides. Well, what did I just say? What does the inverse tangent do to the tangent?
Doesn't it kind of like cancel it?
Good, it cancels it out. Exactly, because think about it. Subtraction always cancels out addition. Division cancels out multiplication. The square root cancels out your exponent. So here, the tangent, the inverse tangent, is going to cancel out the tangent. So what happens is the tangents, they cancel out with each other. So I'm left with theta equals the inverse tangent of 35 over 65. Well, there's no way to know what the inverse tangent of 35 over 65 is without a calculator. So this is where calculators are going to come back. Before we do it, I just want to point something out. Regardless of whichever calculator you own, every single calculator, even the iPhone, has an inverse sine, inverse cosine, and inverse tangent. Do you guys see it on one of these calculators? Do you guys see the inverse sine, inverse cosine, and inverse tangent? Matter of fact, let me zoom in to this one because most people have this one. Do you all see it?
Sorry, but it's a scientific, right?
Yeah. Yeah,
Okay.
scientific.
I have I'm using what the one Microsoft provides, or like the
Like on your
yeah,
computer.
the one on my computer. Yeah.
Well, do you see it on yours? Do you see the inverse sine, inverse cosine, or inverse tangent?
Yes, because like there's many different types of calculators on the Microsoft one.
Okay, so for you it might be a little bit easier, but for anyone who has a physical calculator like one of these, can anyone see it on the screen?
Where it is?
Yeah, where is it?
It's on top of the tangent.
It's on top, right? So inverse sine is right on top of sine, inverse cosine is right on top of cosine, and inverse tangent is right on top of regular tangent. How do I get to that button?
You have to press second because you're
Good.
going to use the second function.
Good. So we're using the second button, all right? So that was all I wanted to make sure. If you're wanting to use those functions, the inverse functions, you have to hit the second button first. And that goes for all calculators. See right here? Same thing for this one, and same thing for this one. So on my calculator, I'm trying to figure out, I'm doing the inverse tangent of 35 over 65. So the first thing I do is I'm going to do 35 over 65, see what that equals, and then hit the second button, and then the inverse tangent, and I get 28.3. So try it on your own, see if you also get 28.3. Yeah, we're going to round to the nearest tenth. And always read the question. The questions will always tell you what to round to. So here we're going to round to the nearest tenth. Does anyone want me to show it one more time? Okay, so it was 35 over 65. So I do that first. 35 over 65 equals this, 0.538, whatever. Leave that on the screen, hit the second button, and then hit inverse tangent. And I got 28.3. Is anybody getting a different number and would like me to try and figure out why? Okay. So where to go? Over here. So we did the inverse tangent of 35 over 65. So I know that theta is equal to 28.3 degrees. Okay, my Apple Pencil doesn't want to sync. Give it a moment. There we go. Okay. Questions on how to use the inverse functions on your calculator. We are going to do a few more problems together, so don't worry if you're a little confused. You got it? Okay. Okay, let's do another one. So here's my missing angle. I'm going to call that one theta again. I like using theta. Which ratio should I use in order to solve for theta? Sine, cosine, or tangent? Good. So sine and then inverse sine. So I'll start with the sine of theta equals 8 over 10. Okay. But then I'm going to have to take the inverse of sine. So sine, inverse sine. And we do it on both sides because this is just an algebraic equation. So theta will be the inverse sine of 8 over 10. So go ahead and do it on your calculator, see what you get, and then we'll see if we get the same thing. Rounded to the nearest tenth. Good, guys. 53.1 degrees. So again, is anybody getting a different answer? I want to troubleshoot that as soon as possible because if you're getting different numbers, depending on whatever calculator you're using, I want to make sure that we're getting it right. Because on a test, it's going to be too late to ask me questions. Going once, going twice. Okay. Here's another. Here's another. Same idea. First of all, figure out the ratio you need, and then we'll use our inverse. So in this case, which ratio should I use for theta? Sine, cosine, or tangent? Okay, sine, no? Good, tangent, tangent. We got opposite over adjacent. The 6 is not the hypotenuse. Don't be fooled. It's almost as long as it, but the hypotenuse is ED. So it's opposite over adjacent, so tan. Tan of theta. Tan of theta is 4 over 6. So to get theta, we do the inverse tangent of 4 over 6. See what you get. $33.7. Good. Perla, what came up on your calculator before you rounded? 33.690. If I'm rounding to the nearest hundredth, what would my final answer be? Nearest hundredth.
33.7.
That's nearest tenth. So nearest hundredth, what would it be?
Oh, the same thing. My bad.
Okay. So nearest hundredth would be 33.69. So that's why I said you got to be very careful. Read each problem very carefully. But nearest tenth, like Jalen said, would be 33.7. Okay. So on a test or a quiz, read it very, very carefully. All right. Questions on these so far? Not too bad, right? All right, do one more on your own. Go ahead and all the way on your own. I won't even start it for you. See what we get. And send me your answers when you've got them. Or just send them publicly in the chat like Janelle's did. That's okay. That's okay. It's a good thing you're right. But yes, that is correct. So let's see how Janelle's came to that answer. Huh? How did she end up with that answer? What do we do first? So 3 over 10, which trig function is that? Sine? Cosine, good. Cosine of theta equals 3 over 10. So that's adjacent over hypotenuse. 3 is the adjacent side. 3 is the adjacent side. So 3 over 10. Well, that's cosine of theta. So in order to get theta, I need to do the inverse cosine of 3 over 10. Which gives me, on my calculator, I get 72.542. What is that number rounded to the nearest hundredth? Nearest hundredth. 72.54, good. What is it rounded to the nearest tenth? 72.5. So let me write this down. To the nearest hundredth, 72.54. To the nearest tenth, 72.5. What about to the nearest whole degree? To the nearest whole degree. Good, 73 degrees. Why do I have to round it up to 73? Well, okay, because when I round to the nearest whole number, that was a 2, but what's next to the 2? A 5. So 5 makes the 2 go up to a 3. Exactly. So I end up with 73 degrees. Okay, any questions on the answer? Any questions on rounding? Questions? What are the places for rounding? Okay, good question. Let me just do a long number and we'll discuss that. So for rounding purposes, this is very important because it is on your quiz and it does come up on Khan Academy a lot as well. So we want to make sure we know how to round properly. So the best way to think about it is think of money, because money kind of has it in the name. Each of the coins that you use kind of tell you. So think about this. Ready? Let's say I have $3,000, 452.67 cents. Okay. 7. The 7 is the amount of what that you have. If this is money, I have 7 what? What types of coins am I taking out of my purse? Pennies, right? How many pennies go into $1? 100. So that's my hundredths place. The 6. 6 is what type of coins? Not nickel. What am I taking out of my purse if I have 67 cents? 6 dimes and 7 pennies, right? How many dimes go into $1? 10. So this is my tenths place. Then I've got my ones place, that's your dollars. It's a ones place. How about the 5? What type of bills am I taking out for the 5? Tens, yeah. So it just keeps going like that. Tens, hundredths, thousands, and so forth. Does that help? So always think about it like money, and then you'll be very, very helpful. Now, if it keeps going in the decimals place, let's say I have an 8 over here. Obviously, that doesn't really work out so well for money, but you just keep following the pattern. If the previous one was the hundredths place, this is going to be the thousandths place. And the TH at the end, when it has a TH at the end, that's how you know it's a decimal place. If there's no TH at the end, then you're talking about a whole number. Okay, any questions on rounding? Okay, you're welcome. All right, so now let's take a look at this final question, kind of putting it all together. We're going to solve the triangle completely. So that means we're going to find all of the possible sides that we're missing, all of the possible angles that we're missing. So we're going to kind of like put it all together. Starting with, I don't know, let's actually start with angle Z. I'm feeling like doing angle Z to start with. Angle Z, let's just call that our theta. How do I find the value of angle Z? Which function should I use? Close, Tyrone, not sine, because sine requires the opposite side, but I don't know the opposite side. So it's cosine. Good. So cosine of theta would be what over what? Adjacent over hypotenuse. Good. So 4 over 9. So theta, if that's the cosine of theta, what do I do to 4 over 9? We take the inverse cosine. Remember, in order to get theta out of there, we need to let it out, right? We got to undo the cosine. So I'm going to use the inverse cosine of 4 over 9. Using your calculators, What do we get? And look what it says, round it to the nearest hundredth. $63.61. Good. Is anybody getting a different answer, or would anyone like me to explain how you get 63.61? Okay. So the measure of angle Z is 63.61 degrees. But I'm still missing a few bits of information. How can I figure out angle O? If I know angle Z, how do I get angle O?
Add C and E.
Yeah, because what are they supposed to add up to?
180.
If altogether they're 180, then I just gonna take that away from 180, or even easier, I can just take it away from 90, because I know that Z and O have to add up to 90. Since E is already 90 degrees, then Z and O have to add up to 90. So 90 minus 63.61 gives me 26.39 degrees. That's angle O. Okay, so now I'm just missing one piece of the puzzle. I'm missing OE. There are two possible strategies to find OE. What's one strategy? Good. One way is to use the sine of Z. Since I already know what the sine of Z, what Z equals, then I can figure it out. So we can either do, let's do strategy number one, as Perla suggested. If my Apple Pencil feels like cooperating today. Sorry. Give it a moment. I don't know why it likes to take its time. It doesn't want to write. RIP. Okay, but let me try to use words. So the sine of theta would be what over what? There we go. We're back. Okay. Sine of theta would be what over what? And let's call this x. Good. OE over 9. So it'd be x over 9. We already know what theta equals because we already calculated it before. Theta is 63.61. So sine of 63.61 equals x over 9. What do I do to both sides to get x by itself? Times 9. Good. Okay, so in your calculators, you can go ahead and plug it in. What is 9 times the sine? Now remember, we're not doing the inverse sine, just sine. 9 times the sine of 63.61. .06. Exactly, 8.06. So that kind of summarizes everything we've done in the last couple of days. We have figured out how to find a missing side length, and we have figured out how to find a missing angle. For a side length, you don't use the inverse of the function. You don't need to. But for an angle, you do. So make sure that we understand how to do both. At this point, do I have any questions? Because we're about to spend some time practicing. So remember how I said yesterday, don't worry about the assignments that are on Khan Academy. That's because I want you guys to work on them right now. So go ahead, log on to Khan. You'll see 2 assignments. There's solve for a side in a right triangle and there's solve for an angle. You're going to spend the next 25 minutes working on those assignments, and I want you to at least complete one, if not both. Anything you don't finish is due by Sunday at midnight. So go ahead, and now I'll spend 25 minutes working on that. I am going to pause the recording. Janelle's, remind me to start recording again when we come back, okay? It's on you. Okay. All right, so I'm going to pause the recording. So if you get a question like this one where you don't have a picture, draw one out. You've got to do it, because the more you rely on your head to do things, the worse it's going to be. You want to make sure that you're always drawing these out. So here we go. A right triangle has a hypotenuse of 18 feet and a side length opposite angle A of 12 feet. What is the measure of angle A to the nearest degree? So if it doesn't tell me which one is angle A, does it? But I can just label it wherever I want and just start putting down the information. So the hypotenuse is 18 feet. And the side length opposite of A is 12 feet. So which side length, let me label this, which side length is 12 feet? Which one am I labeling with a 12? Guys, let's go. The more time you spend not answering me, the less time you have for your quiz. Okay, BC. You think BC or you know it's BC? We got to know it by now. Do we agree with Emily? Okay, I'm just going to sit here and let you guys waste your own time. Okay. I do have students in this class. Okay. Yes, the side opposite of A is 12 feet. So that's my 12. Now I'm solving for A because I don't know what A measures. So which trig function should I use for theta? Sine, cosine, or tangent? Good, sine. Sine, sine, sine. Opposite over hypotenuse. So sine of theta is 12 over 18. I'm looking for theta. What do I have to do to both sides? Good, Janelle's the inverse. I need to get theta out of there. Inverse sine of both sides. Okay, so that cancels out my sines. I'm left with theta equals the inverse sine of 12 over 18. Calculators. And we're going to the nearest degree, so to the nearest whole number. Go ahead and figure out what is the inverse sine of 12 over 18. Don't forget to use the second button. And Janelle says 42. Good, on my calculator, I get 41.81. So if I'm rounding to the nearest whole degree, whole number, that's the ones place. I look over at my 8, I know I have to round up to 42 degrees. 42 degrees. Any questions on this problem? This is very similar to what you were just working on Khan Academy. So remember, the process is always the same. Set up your equation using one of the functions, sine, cosine, or tangent. Set it up, fill in everything you know, And then we're going to just solve algebraically. Questions on this one? Questions going once? Going twice? Okay. I'm gonna skip this one because it's not. Okay, I want to do one of these. Sometimes you'll get a problem like this where you have a drawing. Same idea applies though. So in this case, you are standing 30 meters away from the base of a building. The top of the building lies at an angle of elevation. So that's the angle between the ground and the hypotenuse of 50 degrees. So that's my angle of elevation. Angle of elevation. What is the height of the building? So we don't know the height of the building, but we know almost everything else. Which function, which trig function should I use in my equation this time? I'm looking for the height. Good, Janelle's. Tangent of 50 degrees. The tangent of 50 degrees is x over 30, opposite over adjacent. So now in this case, do I need to use the inverse tan in this case, or am I doing something else? No, what am I doing here? Good. I can solve for x by multiplying both sides by 30. Okay, everything is algebraic. If you're trying to solve for x, you gotta multiply both sides by 30. So I don't need to use the inverse function in this case. So x is gonna be 30 times the tan of 50. Calculators, see what you get. Okay, we get x equals 35.75. What does that round up to? The nearest whole number? $36. Questions on C? On this problem? So Janelle's is feeling good, but how's everyone else doing? I want to make sure that we're all understanding, because by the end of class today, you should feel very good about this type of question so that you can do it on your quiz. Now, the best thing you can do is practice. So if most of you did not finish Khan Academy, do that first. Don't try to attempt the quiz until you finished your homework, because your homework is your practice. The more you practice, the better you're going to feel about it. We'll do one more and that'll be it, okay? Good, here's a good one. The diagram below shows the ramp connecting the ground to a loading platform 4.5 feet above the ground. The ramp measures 11.75 feet from the ground to the top of the loading platform. Determine and state to the nearest degree, the angle of elevation formed by the ramp and the ground. So which one's my angle of elevation? Is it this one, number 1, or number 2?
Number 1.
Number 1, good. So I'm going to call that one my theta. Which of my ratios should I use? Sine, cosine, or tangent? Good, Perla. Sine, because I have the opposite and I have the hypotenuse. So we're using sine of theta. Sine of theta is 4.5 over 11.75. Okay, now in this case, what am I doing to get theta all by itself? Good, Janelle's. Again, this time we're going to use the inverse, because what are you trying to get alone? you're trying to get theta all by itself. Well, in order to break it out of the sine, you have to do the inverse sine of both sides. Okay, so I cancel out my sines. I'm left with theta equals this inverse sine of 4.5 over 11.75 using our calculators. So when you actually plug it into your calculator, 4.5 divided by 11.75, you get a decimal, take the inverse sign of that decimal, and yes, you get 22.518. If I'm rounding it to the nearest whole degree, we get 23 because I have a 2. Next to it, I have a 5. I have to round up to 23 degrees. So theta is 23 degrees. Any final questions on solving for an angle or solving for a side length? Okay. Now, like I said, you will not have time to finish. Obviously, there's only 4 minutes left of class. However, I do want everybody to open the quiz so that you can all see what's on it and you will know what you need to study in order to get those answers correct. Okay, so as soon as it posts in just a moment, because I'm about to post it, look at it, see what's on it, study, do your homework, finish all of that and practice. That way you can get it right. It's not due till Sunday at midnight, but the sooner you do it, the better. I don't want anybody leaving this until the last minute. And those of you who have not been good about submitting assignments, look on the grade book because your progress reports are due tomorrow or due today, I think. So look into your grade book, know what you're missing, and go back and make it up because a lot of you guys have not been doing your homework on time. So check it out. It just posted. You have 4 minutes to just take a look at what's on the quiz. Make sure you study. I will be posting the video recordings, which I know I'm a little bit behind, but I'm posting them today. So you have a little bit of time this weekend to just review your notes from the week and get this quiz done on Sunday. Okay, so just spend the next few minutes taking a look. No need to actually do the quiz quite yet. But if you have any questions, let me know. All right, y'all. Have a great weekend. I will see you guys on
Bye, Mom.
Monday. Thank you, Janelle's. Bye, guys.